All right, so a review kind of quiz today. We had two problems. First one is water's leaking on the floor, forms a circular pool. The radius of the pool increases at 3 centimeters per minute. How fast is the area of the pool increasing when the radius is 13? How fast? That means it's a related rate. Okay? So let's draw the situation. We have a pool of water growing at some r, and we know the area of a circle is pi r squared. So that's the figure and the formula. Our two related rates, the one they gave us was the radius was changing at 3 centimeters per minute. In the second sentence it said that. And then it said how fast is the area. So what we don't know is dA dt. How fast is the area changing when the radius is 13, when r is 13. That's our unknown. All right, I got all this great stuff. We realize that area and radius are changing. We have to differentiate the blue implicitly. So derivative right now, I don't have to do any substitution. There weren't two variables. Very straightforward problem. The derivative of a is 1 dA dt, or just dA dt. The derivative of the other side, derivative of pi is 0, so we'll ignore it. The derivative of r squared is 2r, so 2 pi r dr dt. Plug and chunk time, exactly. Plug and chunk time, I'll do it in green, because we don't know dA dt, we know r is 13, and we know dr dt is 3 centimeters. So dA dt equals 2 pi 13 centimeters times 3 centimeters per minute. Let's see here. 6 times 13 is 60 plus 18. Is it 78 pi? All right, so the answer to this one is 78 pi centimeters squared per minute. That is the rate of change of the area. All right. The second one, doing black. For each problem, use implicit differentiation to find dy dx in terms of x and y. And then for this one, I'm going to pose the question, could we solve for y and just find y prime? The answer is yeah, we can. So, first thing I'm going to do this implicitly and work our way down the page. So, I take the derivative here, and I get rid of the number 2 so I don't get confused. The derivative of y cubed is 3y squared. We're doing with respect to y. 3y squared. And I'm not going to write dy. I'm going to write dy and then divide by dx in my head. And just write y prime. The derivative of 3 is 0 dx. 0 dy. Doesn't matter. The derivative of 5x squared is 10x dx. But I've divided by dx in my head. So the answer to this problem, because this is 0, and cross out, y prime or dy dx equals 10x over 3y squared. That's the answer. Everybody, I want to be clear that there's another way to do this one. And I pushed the space bar on my worksheet generator that made this quiz until this came up. Because do you guys agree that I could solve this for y by taking the third root? If I do that, I can take y prime of this. It's a chain rule. 1/3 5x squared minus 3 to the negative 2/3 power times derivative of the inside is 10x. So what I'm telling you at this point is that this red derivative is the same as the black one. And if you would substitute in, you could do the substitution and prove it. All right? I will tell you right now. Yes.
I mean, to me, the odd is to go from doing simple as the first one to something complex to the second one.
Absolutely, that's the right question. Yes. You don't want to. You don't want to. You're right. And that's why I'm excited you say it, because it would be crazy to do the green and red at the bottom. Keep it simple, stupid. I'm with KISS. And that's why you want to do this. Now listen, the only thing is what do you have to do to use this derivative? You have to know the point x comma y, right? What's nice about the one down here, if you couldn't figure out y for some reason, what value do you need? Just x. You can figure out y up here, and that's why you have handy-dandy calculators, all right? All right. The implicit differentiation usually will have product rules in it on the test. The related rates will almost always have two variables going forward. All right, we'll practice again Monday. Same way, we'll go 7 minutes.